In this video, we're going to look at word vectors from Google. We're going to download the pre-trained vectors from Google at this location, and then we're going to load them into GenSim and see what they can do. So here we are. So we can download them from here, Google Code Archive, scroll down, Google News Vectors -300 bin.gz. It's trained on the Google News dataset, which is about 100 billion words. Then we're going to load them into GenSim. GenSim has some documentation on this, which we see here. So I've already done the first one. So import gensim.models.word2vec as word2vec. So we've imported the model, and then we're going to use word2vec.word2vec.load-word2vec format, Google Vec file, and load it as binary. We're going to get the familiar pattern libraries not installed, but don't worry about that. So that takes a couple of minutes. I've already done it. So we can look at the first few keys. So in Python 3, you have to take a dictionary and create a list, and then you can look at some of them that way. So here we are. We see that they are not lowercase, that some of the more common words patterns are put together. So we can now look at what is the vector for a word like mouse. We get a 300-dimensional array. So what is most similar to mouse? What it's doing is it's computing the cosine similarity between mouse and the other words. And for cosine similarity, -1 means opposite, and 1 means pretty much the same, and 0 means they don't have anything to do with each other. So here it's interesting. I was thinking mouse in terms of a little mammal, but it was thinking computer mouse because it's reading news articles, although mice comes up number 3. If we look at something that maybe doesn't have multiple meanings, such as house, we get houses, bungalow, apartment. Makes a little more sense. We're getting values like 0.7, which is pretty similar. We can then look at the similarity between any particular two words with model.similarity. 0.76, cat and dog are pretty similar. What about cat and rock? We expect it to be less similar, and indeed it is. Notice that similarity is not always the semantic similarity that we would think of. So bad and good are generally opposites, but they tend to appear with similar words around them. So actually, this type of model is going to consider them pretty similar. 0.71. So that's the general word vectors from Google. Let me restart and clear output because we're going to load in some new vectors from Freebase. So these are Google trained over Freebase. So if we go to this same website, but down a little further, we see that they're Freebase vectors. So Freebase is a database of all kinds of normal information in our lives, like movies and actors, and it's almost like a little bit of a Wikipedia. If we load this in, and it takes a moment, we're going to have vectors just like we did before, except these vectors are going to be of Freebase terms. So we can do as before. We can look at the first few vocab to get a sense of what's in there. They start with EN for English. There are a few other ones in there that don't start with EN. So if we look at the model for Marvin Minsky is one of the pioneers of artificial intelligence. We see the familiar 300-dimensional vector. So we can do something interesting now. We can say, okay, let's take the movie Pulp Fiction. What is similar to that movie? And it takes a minute because it's doing the same thing it did before, doing the cosine similarity. Okay, here we see it returned Quentin Tarantino as the most similar, Reservoir Dogs, Jackie Brown, Good Will Hunting, Vincent Vega. So in this video, we've seen how to download two kinds of vectors from Google. We can download regular vectors of just words and possibly pairs of words that are paired together if they go together often, and vectors from Freebase, which can be good for semantic types of applications.